Chapter 5, it is integral, okay? So before starting the sigma notation, let's talk about the big picture about the integral, okay? Basically, we would like to talk about the area under the curve, okay? But keep that in mind, there's no way to calculate the exact value under the area under the curve, okay? So we know just couple of things, okay? Area of rectangle or square, okay? And area of triangle, which is half of them, right? And we know the area of circle, okay? Just like in a couple of more, but all those based on these three basic calculation of area, okay? But if you have curve, and if you have to find area from here to here, I'm talking about this area. Keep that in mind. There's no way to calculate this one, okay? But we're going to talk about how we can calculate this one in calculus, okay? It is really concerned with the limit, okay? So, to understand this one, we have to start from here, the sigma notation, okay? But don't worry about it. We are not going to talk about the detail or techniques about the sigma notation. But as long as you understand the meaning of this notation, that'll be fine, okay? So look at that. This is sigma, okay? Or we're gonna just simply say summation, okay? Because we're gonna add up everything, okay? So this I is index, okay? Index equal to m. The bottom one is the starting point, and all those are integer. And the top one, n, is the terminal point, okay? So it is integer. We're gonna just increase by one, and we're gonna add up everything. Look at that. Since your index I is changing from m, your index is here, right? Can you find this one in sequence? This m will be m at the first time, and then you're going to add 1 and 1 and 1 and 1 and 1, right? And then finally, it will be terminate at am, right? So let me give a numerical example. Okay, here we go. Look at this, okay? So let me give one example, okay? So you have a1 plus a2 plus a3 plus and so on. You could have A10, okay? So can you figure out which one is the index? Look at this number, changing from 1, 2, 3, 1 by 1, and until 10, right? This circled part is index, we're going to notate by I, okay? Then in a sigma notation, it can be written by the sigma. Index I is changing from 1 to 10, your sequence AI. Does it make sense? Or if it's not this kind of sequence form, but if it is the function form, then let me show you what I'm gonna do, okay? Here we go, another example. If it is x plus 1 to the 4 plus x plus 2 to the 4 plus x plus 3 to the 4, x to the plus 4 to the 4, and x plus 5 to the 4, okay? So can you figure out which one is the index? Yes, it is easy, right? Just changing value, right? Here we go. 1, 2, 3, 4, and 5. This is index. So we're going to notate by I instead of number, okay? In the sigma notation, okay? So it can be written by sigma. Index I is changing from 1 to 5, and your function is x plus I to the 4, okay? So this is the way to write your, your summation of the equation as the sigma notation, okay? So what about this problem? That's really easy, right? Just you can easily find the index, and it is changed from 1 to 6, right? Then we're gonna try to plug in 1 from 1 until 6, right? So this sigma is equal to 1 over 1 plus 1, now 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, and the last one. Okay, this is the way to write your sigma notation as single summation form. Okay, so you can just evaluate this one by yourself. Okay.